Heating, ventilating, and air conditioning, also known as HVAC, are systems that require control systems to make them function properly. A typical household furnace and air conditioning system relies on a thermostat to determine how long the furnace runs or how many stages of cooling are required to meet the temperature set point. A typical residential thermostat might also control whether the furnace fan operates intermittently or continuously. Night setback scheduling is another feature provided by some programmable residential thermostats. While it may be simple within your home, control systems for commercial buildings are far more complex. As the size and complexity of commercial HVAC systems increase, the control systems must also increase in complexity. Regardless of how complex a control system is, it has four necessary aspects: control set points, control sensor inputs, a comparison device, and control system outputs. The occupant or building operator adjusts control settings to establish what the HVAC system is supposed to accomplish. For example, the desired room temperature and humidity, fresh air requirements, or room pressure requirements can be adjusted. These are the control set points. The second aspect of a control system involves sensing the conditions in the room, or HVAC system, and comparing those conditions to the set points. For example, if the HVAC system needs to provide a certain amount of outside air, an airflow monitoring station by Ebtron would be installed in the outside air intake duct to sense the outside airflow. Or, if a hot water heating system requires a certain water flow rate, an Onicon flow measuring device could be employed. Onicon meters can measure water and energy flow in hot water and steam systems. If the concentration of refrigerant gases in a chiller room must be maintained at safe levels, air reps can provide an MSA gas detector to sense the gas concentration in parts per million. For data rooms where water could be detrimental to computer systems, a system of PermAlert sensors could detect moisture levels. These are all great and important examples of control system sensors. Sensors work in conjunction with the control system set points to provide information to a third aspect of typical control systems, the comparison device. The comparison device, or central controller, could be considered the brains of a control system. By comparing the sensed value to the set points, the comparison device determines what actions are required of the HVAC system. A typical household thermostat contains all three functions. The thermostat senses the room temperature, compares it to the set point entered by the occupant, and decides how the furnace and air conditioning system should respond. The comparison device can be complex in commercial HVAC control systems, involving multiple control inputs, computer logic, custom programming, and multiple control outputs. These systems are often referred to as direct digital control, or DDC. Systems can manage the HVAC system serving areas of a building, whole buildings, campuses, or even multiple sites from a single central controller. Such systems typically have scheduling capabilities to instruct the HVAC systems to behave differently based on whether or not the building is expected to be occupied. AirReps offers the Daikin Variable Refrigerant Volume, or VRV systems, which consist of outdoor heat pumps and multiple indoor fan coils. With VRV, multiple zones in a building can be controlled to their own temperature set points. The VRV system requires a robust control system, which is provided as a package with the VRV system. It can incorporate a central controller, known as the iTouch Manager, or ITM, the brains of the VRV control system. In addition to ensuring proper operation of the VRV system, the ITM can also function as an affordable DDC system that can control all HVAC systems in a building. This is done by communicating with the control system components via the BAC net communication protocol. The ITM can control exhaust fans, dampers, pumps, and other HVAC devices with the BAC net capability, making it an affordable solution for relatively simple DDC system requirements. The ITM can be the central controller for a building or even a group of buildings. The fourth aspect of a control system is the control system outputs. After the inputs have been compared to the set points, the central controller issues a control output. The output signal directs output devices how to behave to achieve the desired result. One example of an output device is a control valve that might be used as a hot water heating coil in a large commercial air handler. The output signal might direct the valve to open and allow more water to flow. AirReps offers the Delta P valve by Flow Control Industries. These valves are well engineered and thoroughly tested, designed with the goal of reducing energy consumption by optimizing the HVAC system operation. Another example of a control system output might be fan speed control. If, for example, the central controller determines an airflow is below a set point, a variable frequency drive, or VFD, might receive an output signal to increase speed, resulting in more airflow. AirReps offers a complete line of Danfoss VFDs. Some output devices have the capability to think for themselves. That is, they can accept an input, compare it to a set point, and adjust the output automatically. For example, a Danfoss VFD can be configured to accept an input signal from a pressure transducer, compare it to an internal set point, and issue a command to adjust the fan speed. Smart devices like this do not require interaction with the central controller. An important quality of an optimized control system is the ability to verify that the control outputs are having the desired effect. That is, if a control system instructs the HVAC system to perform a task, it needs to be able to verify that that task has been performed accurately. A feedback loop or closed-loop control system provides this information. Most modern HVAC control systems employ this method of control. Our team of engineers and account executives at AirReps can help specify control components to ensure proper feedback in a control system. While the four aspects of a control system we have discussed are necessary for a closed-loop control system to function, there is an additional feature that can provide great value: remote monitoring and set point adjustment. Some household thermostats can now be monitored and adjusted from anywhere using a smartphone, which is a nice convenience for homeowners. For commercial buildings, however, remote monitoring can offer tremendous value. The ability to monitor the behavior of the control system, including trend logs of control point values, can enable building operators to reduce system maintenance costs and improve system performance. The Daikin Hero system is a cloud-based monitoring system that can do just that. Imagine being able to remotely monitor a building's VRV system performance. With Hero, a building operator can view the refrigerant system operation in real time. Any system alarms will also be visible, making troubleshooting easier. With the Hero monitoring system in place, system efficiency and occupant comfort can be optimized remotely. AirReps offers many control components that can be employed in building control systems. In this video, we mentioned just a few examples of our full lineup. Be sure to visit airreps.com for the full line of HVAC equipment and control devices, or connect with your account executive today.